So let's consider a very practical question. Assuming we are given a question like this, and we are asked to find the current through this circuit. Our V source is 12 volts. We have our first resistor R1 being 1K, and then the second resistor being 100 ohm. The first question is, let's consider the current that we can find. Let's find the current that is going through this circuit. From our derivation, we have current to be I equal to Vs on R1 plus R2. So we can quote that Vs, sorry, I is equal to Vs on R1 plus R2. So our I become Vs, which is 12 volts, on R1 is 1K. 1K is the same as 1,000. So 1,000 plus 100 ohm. We get our I to be 12 over 1,100. If we should do the calculation, we should get something like uh, 0.0109 amps, right? And we know we can convert this to milliamps by dividing through by 1,000. So by dividing through with 1,000, we'll have to get 1, 2, 3. We get 10.9 milliamp. 10.9 milliamp. This is our current. This current is what is running through the circuit. All right. Then the next question we may be asked, or the next thing we need to find, may be the voltage drop in resistor 1. So we say V1, voltage drop in resistor 1. So we can quote again from here our equation 3, right? V1 will be Vs on R1 plus R2 times R1. So you can see that V1 equal to Vs on R1 plus R2 times R1. So quickly we say 1 over 2, 12 over 1,100 times R1 is 1,000. Okay, so this is the same as saying that the current times the resistor. In fact, there are so many ways you can find that. You see, V1 is the same as IR1. V2 is the same as IR2. So we may not need to go through this process at all. So V1 is equal to uh, 0.0109 times 1,000 times 1,000. So it becomes 10.9 volts. 10.9 volts. Let's calculate for the voltage drop in resistor 2. So V2, without wasting time, is IR2. 2. Okay, so V2 is equal to I, which we know already, uh, 0. Let's say, yeah, 10.9 milliamp, right, times resistor 2, which is 100 ohm. What will be our V2? Our V2 is going to be something like 1.09 volts. 1.09 volts. Now let's do a little analysis here. The supply voltage is 12 volts. If we are to take this as what George Ohm said, it means that the supply voltage should be equal to the drops here. Again, Kirchhoff also said that the same Kirchhoff first equation. Okay, he said that the summation of all the drops or the total voltages in a complete loop is equal to zero. Is equal to zero. So let's find out what will happen. Let's sum up all this and see. We have the equation which says that Vs equal to V1 plus V2. Let's see if that will be true. Vs is equal to, let's substitute this for V1. 10.9 volts plus V2, which is 1.09 volts. By addition, we could see that Vs equal to 12 volts. Vs equal to 12 volts. Right, and it's the same here. Vs equal to 12 volts, which verifies both Ohm's law and Kirchhoff's law. So we are done with the Kirchhoff voltage law, which states that the total drop or the total voltages, the summation of all the total voltages in a circuit is equal to zero. The summation of all the voltages in a circuit is equal to zero. Okay.